So, dear students, so hope you all are doing well. So, after our discussion on the different parameters related to motion, that is displacement, velocity, speed, acceleration, retardation, etc. Now we are switching over to the graphical representation of motion. Okay. Now, basically, graphs they have a lot of advantage to express certain information related to any event that is occurring in our day-to-day life. That is what I'm trying to say is, suppose if you people watch football or cricket or any other sports, or maybe any other data, maybe from health, from COVID-19 issues, anything. So what they do is they provide a graphical analysis of what is being observed. Okay, so for example, in cricket, they show the statistics and a graph of how many runs were scored in which over, and with that they express it graphically, isn't it? So that we can analyze it perfectly and easily. Now, just to and even in football, they give you the possession and the amount of strikes that they have made. They express everything in terms of a graphical analysis, isn't it? So that we can extract the information out of the graph, isn't it? We don't have to say blah blah blah. We don't have to express in terms of words. So graphically, it can be interpreted. So that coming to that line only. So from today we are going to discuss about the graphical representation of motion. So initially we'll discuss about the displacement and time graph. Displacement and time graph. So displacement and time graph means we have a data here. So the data is time. We are plotting time in second, and we are in the y-axis we are plotting displacement in meter. Okay, we have the data initially when time t equal to 0, d equal to 0. So this is our first point, t equal to 0, d equal to 0. This is just a random data that I have written. Okay, then after let us take the axis also, the coordinates also. So 5, 10, 15, it won't be perfect. Okay, 20, 25, 30, 35. So 5, 10. Actually, I should have been using a scale here, but doesn't matter. I just want to teach you the content. So initially when time equal to 0, d equal to 0. So this is the point. When time equal to 10, d equal to 5. Time equal to 10, d equal to 5. So it will be somewhere here. This is the second point. Time t equal to 20, d equal to 10. T equal to 20, d equal to 10. So it won't be perfect, I'm telling you, but still. Okay. Time t equal to 30, d equal to 15. 30, 15 will be around here, roughly. Okay. 40, I have taken till 50. 40, 45, 50. T equal to 40, d equal to 20. So 40 around, it will be around here. So it's just a rough diagram. Okay, a rough graph. 50, 25, 50. So let's take it around here. Okay, so we'll join these points. We'll join these points. So after joining these points, what we can see is it is a straight line. You can see it is a straight line, isn't it? Why it is a straight line? Because this represents a uniform motion. What is uniform motion? Uniform motion means the type of motion where equal distances are covered in equal intervals of time. For example, in 10 seconds, 5 meters were covered. In the next 10 seconds, 5 more meters were covered. 5 plus 5 is 10. In the next 10 seconds, 5 more meters were covered. In the next 10 seconds, again 5 more meters were covered. So the particle or whatever is tracing equal distances in equal intervals of time. That is, in 10 seconds, it is traveling 5 meters. So the graphical interpretation of it gives a straight line. So displacement time plot is a straight line for uniform motion. Now it is a straight line. Now what is the big deal then? From here what we can do is, from here we can calculate the velocity. What is velocity? Velocity is rate of change of displacement. Now how will you do? We can calculate the velocity from the slope of this graph. Okay, from the slope of this graph. We can consider any 2 points. Let's consider suppose 20 and let's consider say 10. Okay, let's consider 20 and 10. Okay, now if you consider 20 and 10, what we can do is we can make a graph out of it, so that if we take the slope from slope of it, we'll get our velocity. Now velocity is rate of change of displacement, isn't it? So displacement will be d2 minus d1 divided by t2 minus t1. What is d2 and what is d1? That you have to understand. This is d2 is 20 and d1 is 10. So 20 minus 10 divided by, no, what I am trying to do is velocity is rate of change of displacement, no? Rate of change of displacement. So actually my graph is not perfect, no? Okay. So d2 is 20, d1 is 10. And for corresponding to d2, corresponding to 20 meter, we are having our value as time as 30 meters. So this will be t2 and this will be t1. So t2 is 30 and t1 is 20. So from here we will get 10 divided by 10, that is 1 meter per second. So 1 meter per second is the velocity of this trajectory. Are you understanding? So this is the slope of the graph. Slope. Now you can consider any 2 points. You can, provided your graph is perfect. My graph is not that perfect, but hope you all understood. What I am trying to do is I am plotting the graph. This represents a uniform motion as it covers as the particle traces equal distances in equal intervals of time. Now we consider 2 points on the y-axis, that is the displacement axis, and we draw a horizontal line. There is a point at which it touches the graph, I mean the plot, the straight line, and you drop a vertical line corresponding to it. On dropping a vertical line corresponding to it, we get one term each on the x-axis. So the first term here is d1 and the second term here is d2, and the first term here is t1 and the second term here is t2. 2 time intervals and 2 displacement intervals. So rate of change of displacement per unit time. So this will give you your velocity. So this is how you compute the velocity from the graph itself. So we extracted the information, isn't it, from the graph. We didn't calculate anything. We just plotted the graph, and from there we just extracted the information that velocity is equal to 1 meter per second for this trajectory. Okay. Now let us discuss about another data which I have written there. So let me write 40, 50. Okay, let's consider this data as well. 5, 10. Okay, now let's consider time t equal to 0, d equal to 0. This is it. Time t equal to 10, d equal to 5. T equal to 10, t and d equal to 5. So it will be somewhere here. Time t equal to 20, d equal to 7. D equal to 20, d equal to 7 means it will be somewhere around here. No? Sorry, what am I doing? Time t equal to 10, d equal to 5. Okay, fine. T equal to 30, d equal to So d equal to 30, d equal to 10. Somewhere around here. Okay. Somewhere around here. Then 40, 15. 40, 15. My graph will not be ideal, I'm telling you, okay? 50, 21. 50, 21. So when we take the perfect axis, no? When you take the perfect axis, you will see that you will not find a straight line here. However, you are finding this type of graph here. It's not representing a straight line. It is representing a some sort of curve-like diagram, curve-like plot. So why we are not getting a straight line here? Why we are getting a curve here is because in the initial 10 seconds, the particle traveled 5 meters. In the next 10 seconds, the particle traveled only 2 meters. In the next 10 seconds, it traveled 3 meters. In the next 10 seconds, it travels 5 meters. So, the particle is not tracing equal distances in equal intervals of time. So, that is why we are not getting a straight line, but we are getting a curve like this. Are you understanding? If you draw it using a perfect scale in a graph paper or even in exercise copy with perfect scale and perfection, you will find that it's not a straight line. It's a curved sort of graph that we are getting, and it is obvious also. It won't be a straight line as it is not covering equal distances in equal intervals of time. So this represents your non-uniform motion. So what I am trying to say is, for uniform motion, the displacement time graph will be a straight line, whereas for non-uniform motion it won't be a straight line but it will be a curve. Okay, so hope this discussion is clear, and in the next class we will discuss about the velocity time graphs. Okay, thank you so much.